if we can begin this side of the room right here, scooch, scooch, scooch. Any room to walk. Okay. Next. What we're going to do today is we're going to run things in a slightly different order. Keith, here's your quiz. What we're going to do is I'm going to go over yesterday's quiz first. Then we're going to go over yesterday's Do It, which you should have done in class. And then we're going to move into a little bit from yesterday's lesson and then also the beginning of today's lesson. I'm going to leave about 8 minutes at the end of the period for the taking of today's quiz. Okay? Now, if we finish earlier than that, that's great. But I want to go over yesterday's quiz. The results were nowhere near what I want them to be. And I also obviously need to cover yesterday's lesson. So, beginning with this, we'll go step by step and get everything down pat and do a little catch up. Yesterday we spoke about the importance of what's going on. And we talked about consequences. We talked about the consequences of a lack of work. And how at the end of the day, if you don't do your work, who is going to end up suffering? Yes. You are. And, you know, I don't know why when kids get angry and kids get frustrated, their instinct is to shut down. And to kind of give up and stuff, because all you're doing is making your life more difficult. One of the points I tried to drive home yesterday is every kid on the face of the earth doesn't want to do too much work. So if you choose to not produce through the end of the year and you get a poor grade on your final exam, A, every college that you apply to will see that grade. B, you may end up going to summer school. If you end up going to summer school, you will put in somewhere around 70 to 80 hours worth of work. And if you just prepare for the Regents exam normally, you will put in nowhere near that number of hours of work. So you actually, by working harder now, save yourself effort later, okay? So those are important things to understand as we proceed forward. You know, it's supposed to be in the 60s today, so I'm actually going to open this window for the first time in like forever because it is a little warm here today. Sid, Michelle, if that bothers you, you can go over there and just shut it if you want, okay? All right, so which situation could be used or modeled by using a linear function? So the first one says a bank account balance that grows at 5% per year, compounded annually. Now, that's the kind of question we just worked on last week, and it's y equals a times b to the x. Does that look like a linear equation to you?
No.
No, what kind of equation is that? Exponential, very good. Okay, next. The amount of money saved if you're going up $25 each week. So 25, what would be next?
50,
Next,
75,
next.
100,
Does that, 125, does that look linear?
Yeah.
Linear means there's a constant rate of change.
Yes.
Is there a constant rate of change?
Yeah.
Yes, a common difference is arithmetic, which is linear. Next, the signal strength of a phone cell service that decays by 0.3 every 5 miles. This is going to be exponential also because it's 0.3 of whatever exists. So let's say in the first case it exists with 30. 0.3 of 30 is 9. Then that knocks it down to 21. So 0.3 of 21 is about 6.3. So that knocks it down to about 15. And then 0.3 of 15 is 4.5, which knocks it down to about 11. And 0.3 of that is 3.3. So it's getting less and less and less every single time. That's not linear. There's not a common difference. Or it's not going up or down by the same amount. And the next, the concentration of medicine in a person's body that decreases by 15% every 20 minutes. Again, this is an exponential graph because it's 15% of differing amounts. It's not 15% of the same amount every single time. So the only one that is linear is choice 2. All right. Remember, constant difference is linear. Not exponential. Exponential is where there's a decay factor or a growth factor in terms of percent or something else. All right, next. Number 2. This was a question that I fully expected virtually the entire class to get correct. And it didn't work that way. I expected struggles with number 1. As you look back on number 1, people thought when you read it was weird? I think most of you probably thought it was weird. But now that you've seen how to do it, how many people look at it and say, I think I could have got that if I understood better what they were looking for, right? Okay, so now that we've gone over it, I think you will be able to better understand. This guy, on the other hand, was very much like the last 2 or 3 days worth of work. So I expected that you would rock on this one, as much as I expected you to struggle on the first one. And it simply wasn't the case. Y equals the principal, what's the principal? 9,000 times 1 plus or minus the percent interest as a decimal. Now what is that as a decimal? 0.0525. How many places do you move the decimal in a percent? 2. You don't make it into the first number, you move 2 places. So when I have 5.25 and I move 2 places, the first place gets me in front of the 5. The next place I have to add a 0 in there. And then t is time in years. But here's the thing. It says it's compounded annually, it's deposited into account. It's building up. When you deposit and you compound and you earn interest, it goes up. So do I use the plus or the minus? Plus. So to go one step further, it's y equals 9,000, 1.0525 to the t. And I did truly expect that that would be a fairly easy question for you guys, and it did not work out that way. So hopefully you see the error of your ways. Lots of different mistakes on that one. I saw 1.525. I saw some people not put the 1, like they didn't add, they just put 1 plus or minus. I saw some people leave off the y equals. Yeah, it says write an equation. Got to have an equal sign for an equation, okay? And I saw some people just write, forget about the 1, and they just put like the 0.0525 or the 5.25, all right? So there were all sorts of mistakes made on that, which means to me you had a hint as to how to do it, but not a clear foundation. Now I think you should have a clear foundation. Any questions on this? Okay, let's go to the next one. Guy and Jim work at a furniture store. All right, so you got one equation here, you got one equation here, and it says determine the value of x that will make their weekly pay the same. Give me some mathematical concepts for same. Bingo! What's the mathematical concept for same? Equals. Guys, all of the hooey in the beginning just means this. That's it. First guy, this equation. Second guy, this equation. Tell me when they're the same. It means tell me when they're equal. And then you just solve, right? I'm going to minus 0.025x, minus 0.025025x. And this gives me 0.025x, 185 plus equals 335. And then I minus the 185. And I get 0.025x equals 150, and then I divide by 0.025, and I believe x works out to be 6,000 if I remember properly. Okay? Pretty straightforward. Okay? Any questions?
No.
Now, what's the purpose of the quiz? First, you got to show you what your mistakes are. Then we go about correcting them. They're a diagnostic tool. All right? So just like when you go to the doctor and he sticks the tongue compressor in your mouth, he says, say, ah, and he looks in your ears, he listens to your heart and your lungs and all that kind of stuff. Then he says, I think I know what the mistake is. We go from there. Minor?
Why is it 0.25 after you subtract it from 125?
Because this is really a 0 here. And if you subtract, that's what you come out with. You have a calculator, so you can just do it on the calculator. It'll tell you. All right? Yeah?
How come you get like negative 10 points? Like, I don't understand why.
I don't know at this moment, and I really don't have time to look, but you can show me later and I'll explain. Okay? All right, so that was the quiz. And I think we've gone over it now. So let's go to yesterday's sheet, which says analyzing graphs 1. Yes?
Very quick, like, I know they're not the same number,
Well, the concepts will be the same. Now, I might, I mean, theoretically, I could change different things here and there, but it's the concepts that I want to emphasize. So if you are fully understanding the concepts, you should get it right, barring a sloppy mistake. And if you partially understand, you should partially get credit, okay? And that's why we give 3 chances, Sarah, not just one. All right, so Eduardo has a summer job that pays him at a certain rate for the first 40 hours that he works here, works, and then he gets a greater salary. By the way, this is very common. Do any of your parents work overtime? All right, overtime is what they call time and a half. So if you made $20 an hour for your normal salary, when you work overtime, you get $30 an hour. And sometimes, like when I was growing up, my dad was a railroad conductor, and if you worked holidays, you got double time and a half. So if he made 20 an hour, normally he would get 50 an hour to work on Christmas, or 50 an hour to work on Easter. So we always celebrated Christmas Eve. So my dad was off Christmas Day to work. Okay, now. It wants you to write an equation for the first piece of the graph and then for the second piece of the graph. Now, if I divide this into 2 pieces, the piece from here to here and the piece from here to here, what word would you use to describe each of the individual pieces? Looking for a word that starts with an L. Linear, good. And linear means it's a line, and what's the general equation of a line? Y equals mx plus b. To figure that out, I need 2 things. I need m and I need b. So in this case, b is really easy. B is 0. Now, to find m, I have to do the slope. And to do the slope, I got to do some subtracting here. That's 198 minus 0 over 22 minus 0, which gives me 198 over 22. And I'm thinking that that's 9. 22 times 9 is 198. So that reduces to 9. And if I go with y equals mx plus b, I will get y equals 9x. And then I could write plus 0 if I wanted to, but no need. Okay? So what does that mean, y equals 9x, as the equation for the first part of the graph, Andre?
The linear graph is moving at a rate of 9, please.
Yeah, and what does that mean in terms of his job?
He said it's
What's he make an hour? $9. Right, he's making $9 an hour. If he works 1 hour, he gets $9. 2 hours, he gets 18. 3 hours, he gets 27. So all you have to do is plug in x for the number of hours, multiply it by 9, and you get the output. So, for instance, if I plugged in with 22, 9 times 22 is 198, and that's where this comes from. Okay, but all of a sudden, bam, it kicks up here. So now, I need to do the same exact thing again, and I have to come up with m and b. This one, however, is not quite so easy. So, I'm going to do, first figure out the slope. In figuring out the slope, 765 minus 630 is 135, right? I subtracted my y's. Over, now I have to subtract my x's. What's 70 minus 60? 10. And 13.5 divided by 10, or 135 divided by 10, I got ahead of myself there, is 13.5. By the way, notice it's time and a half, because half again more than 9 is 13.5. Okay. Does part B say give the equation for the second part?
Yeah.
Okay. And I have to go a little bit further. I have to fill in y equals mx plus b. I know that the slope is 13.5. The problem with this graph is the previous graph was really, really nice. We could just look at where the line met the y-axis to find the y-intercept. Can you see that on this one? No, you can't. So what I have to do is plug in an x and a y. I'll use this one, the 60 and the 630, to calculate what b has to be. So 630 equals 13.5 times 60 plus b. Now, what is 13.5 times 60? I think it's 810?
Yeah.
Yeah, okay, good. So that means 630 is 810 plus b, minus 810 from both sides, minus 810, and I get negative 180 is b. So I go back to this equation here, and I plug in my negative 180, and that gives me y equals 13.5x minus 180. Okay? Any questions? All right, what does the third one say there, Wyatt?
What are the domain restrictions for the context?
Okay, the domain restrictions, very, very, very important. The context of this problem is what? What is the guy doing?
Making money.
Yeah, and he's doing what to make that money?
Working overtime.
Can you work negative hours?
No.
No, not a chance. So the domain restriction in the beginning for working at a single pay rate goes from here to here. That would mean for 0 to 40, and notice I use the brackets to include it, the pay rate is y equals 9x. All the way up until you hit 40 hours work. And that's why parents work overtime. Normal work week is 40 hours. Anything past 40 hours is when you get time and a half. So this restriction, or this function piece, only applies from, it doesn't apply at 40. Anything past 40, all the way up to infinity. And I mean, well, you can't even go to infinity. How many hours could one reasonably work in a week if you didn't get any sleep?
70.
Well, nah. Let's just pretend that someone was like unbelievable and they didn't need any sleep and any rest and they didn't need to go home. 24 times 7 is 168 hours. Now, I know that can't happen, but that would be the biggest possible amount of time you could do in a week. Okay?
Wait, which one is that? Is that the answer?
That's part C.
Wait, Dad, who did that?
Because this is all about how many hours you work in a week. This is the first 40 hours. That's why we restricted it from 0 to 40. This one is everything above 40. That's why I used the parenthesis here. And then it's per week. So I stopped at the total number of hours in a week. Okay? Realistically, nobody ever works 168 hours in a week, but I'm going to allow for the possibility that in some case I can't compute, works. Years ago, this doesn't work anymore, but you know how the teachers go with you on the class trip? Years ago, teachers used to get paid to go on the class trip. Like, I don't know if you know this or not, but like when teachers do something like, say, chaperone or something like that, they get it, like work the cafeteria, I think we get $20 a day or $25 a day. I'd even less take home, it's like $18 a day take home to do that. Now, if we went on a field trip for 5 days, we would get paid in the past hourly wage for each of the days you're on the trip. Now, they don't anymore. Nowadays, you don't get paid anymore. But in years past, you used to get paid for that. So theoretically, if somebody worked like where they went on a trip with you guys for a week, then I could see them getting paid to sleep. All right? Because they are away from home, they are on a trip with you. But generally speaking, I can't see anybody working the full 168 hours in a week. All right, so that is the do it from yesterday. I think we should be able to understand that. By the way, do you remember the phrase we used to describe this graph when it has one and then it breaks off to another?
Piecewise.
Piecewise, very good. It's a piecewise linear graph. All right, so now let's talk about some of the most basic common graphs. And I just want to make sure that you recognize these things and you see them right away. What's this basic graph? Linear, and it's going to be, the parent function is y equals x. Okay? The y-intercept is 0, and the slope is 1. Up 1 over 1, up 1 over 1, up 1 over 1. So the function type is linear. It's a parent function is y equals x. And some key features is it's a straight line. Okay? What's the next graph? Absolute value. Very good. What makes you know that this is an absolute value graph?
V.
Makes a V. Good. And what's the parent function? Y equals what?
Absolute value.
Absolute value of x. Good. Y equals the absolute value of x. Okay. So let's go to now the third graph. What is the parent function of the third graph?
Y equals x squared.
What is it?
X squared?
No, that's not y
I
equals
know,
x
I
squared.
was just joking.
Okay, so what? First off, what's a word that describes the type of graph?
Exponential.
Exponential. Good. So it's an exponential graph. That's the first thing you have to write. And in this particular case, it pays with an exponential graph to look at this coordinate right here. This is the point 1, 2. Okay? So that means it's going to be y equals 2 to the x. Because if you plug in a 1 here, 2 to the 1 is 2. if I went to 1-3, what do you think the exponential would be?
Y equals
Y equals 3 to the x. If I went to 1-4, what do you think it would be? Y equals 4 to the x. So pay attention to that coordinate, it'll tell you what the base is.
Wait, why that?
Because it's lined up with 1, okay? So it's easiest exponent to figure out. Okay, so it's exponential, it's important to look for that point, and in this case, the parent function would be y equals 2 to the x. I guess that's a good parent function. You could do y equals 3 to the x or whatever. I'm a little confused about parent function on that, but to recognize that it's exponential and to know how to find that point goes a long way. All right, next graph, what's that a picture of?
y squared.
Y equals x squared, good, that's the parent function. What is the function type? Not the graph, what is the function type? Starts with a Q. Quadratic, good. What is the shape called? Parabola. Okay? So it's a parabola, it's a quadratic, and y equals x squared is the parent function. And then from there, we do all the horizontal and vertical shift stuff, right? And multiplying by the a in the front. We talked all about that earlier in the year. What's this a graph of, or the parent function?
Y equals square root of x.
Square root of x, very good. And you should recognize that. That has been on the Regents already. So don't say to yourself, that's kind of weird. We've covered it, it's been on a Regents, you need to be prepared for it. To recognize that it's y equals the square root of x, okay? What's this next one a picture of? Does anybody remember? Y equals what, okay?
X to the third.
Yep, y equals x cubed, very good. That's your parent function. I just remember the wiggle here, because cubes can be negative, squares can't. So with squares, I have to come back up positive, but with cubes, I can be negative. So it's like they took the, quote, parabola, it's not exactly a parabola, but the parabolic shape, it's like they took it and they put it down here because it can be negatives. Hey, I'll cough on him on purpose. Now, what is, stop. What is this a
Y
picture of?
equals 3 square root of x.
No, cube root of x.
That's what
Just, right, cube root of x, okay? Y is equal to the cube root of x. That's the parent function. And you should be able to recognize all of those. So, how do we use that? Here's one question from last night's homework. Let's just take a look at this real quick. What is this function type? Everybody, what do we call this type of function? Exponential, good. What's the parent function? Y equals what?
2 to the x.
2 to the x. Maybe the parent function would be like a to the x. I'm not exactly sure. They will never ask you. I don't think they'll ask you on a test what's the parent function. What's the? Oh, you know what? I could give a better name for this parent function. Let's call the general function y equals a to the x. But look at this point. It's 1, 3. So what? Let's do the last part. What's the equation of this one? Y equals what?
3 to the x.
3 to the x. Good. And there are no transformations going on with this one. They're not vertically shifting it, they're not horizontally shifting it. The only thing they could possibly say is, if they said the parent function was y equals 2 to the x, they could say they're multiplying it if they wanted to. I'm honestly a little bit fuzzy on that, but I wouldn't worry about it too much. Okay, take a look at this one. What is the function type here?
Plus square root.
Square root, good. So the parent function would be y equals the square root of x. Now, y equals the square root of x does not work for this, because here's the y, here's the x, right? Let me put this up here in case anybody watches this video later. Here's the y, here's the x, here's the y, here's the x. Is 1 the square root of 2? No. So what would be, I know I gotta have a square root here, I know it's a y equals. What about if I did a half x? Would that work? Let's see, if I plugged in a 1 here, would half of 1 square root be 2? No, that wouldn't work. What about, well, what is the square root of 1? 1. And this is a 2. Oh, maybe it's 2 square root of x. Maybe that'll work. Well, let's go over here and check. If I plugged in a 4 for x, what's the square root of 4?
2.
2, and what's 2 times 2?
4.
So that would work, yeah. So this would be our function then, y equals 2 square root of x. And it kind of makes sense because the classic square root function would go through like this, and doesn't it show it's getting taller?
Yeah.
Right, it's getting higher? So to get taller, I need to multiply it by a number to bring it up. Mia, you with me here? Okay. All right, very good. So that's the review of yesterday's stuff. Now let's look at today's sheet. All right, so I want you to do it very quickly. And then we'll talk a little bit about this question here, and then we'll go on to the quiz. Okay, so let's get the do it done. Make the do it and did it.
I don't know if it was a whole sleeve or not.
No, she really
You
did.
just took a few.
I promise, because I would have had to have someone else.
Just took a few.
No.
Another minute.
Stare at protein drinks.
Okay. Final thoughts? I'll show you a little trick here that's going to make your life a little easier. How many people want to see a really slick trick?
Me.
All right, I'm going to show you a slick trick. Ready? Parent function. Oh, first off, function type. Quadratic. No, parabola is the shape. Function type is quadratic. Parent function. Y equals x squared. Transformations. We got a couple of them going on here.
Up to
I'm moving right. I'm moving one to the right and up two. So that immediately says to me this part of it, right? Right? But I'm not taking into account this. So I should write out the transformations, but I don't have room. What you said before, it's going one to the right, up two. But there's one other thing going on here. If I look at a normal parabola, like I'm just going to do y equals x squared. Here's what I get. I get when x is -2, y is 4. When x is -1, y is 1. When x is 0, y is 0. When x is 1, I get 1. When x is 2, I get 4. Okay? So what do I normally go up by from the turning point on either side? Like here's the turning point on either side. What do I normally go up by?
1.
1. In this problem, what does it go up by? 3. So I need a 3 in front. So if you want an easy way to find out what the number in front is, just ask yourself, I'm supposed to go up by 1s, that's what the parent function does. What am I actually going up by? I'm going up by 3. So if instead it went to the point 26, what number would go in front?
2.
No, if it went to 26 up here, what number would go in front? I'm going up how many? 1, 2, 3, 4. If it went up to here, it would be 5, and so on. So that's all you have to do is look and see. It's supposed to go to here. How many does it actually go up? If it goes here, it would be a half. If it goes here, it would be 2, 3, 4, 5, and so on. So that's a real quick, easy way to tell you what the number in front of a quadratic has to be. All right, any questions? All right. What do we got time-wise? I think we got like 2 minutes or so. I want to make sure you have what I think is a reasonable amount of time for the quiz. So let's just take a look at this here. During tryouts for a track team, Bob's running 90-foot wind sprints by running from a starting line. Here it is. He sprints to the wall. Of course, he's got to slow down by the wall because he's going to turn around. Otherwise, he'll do a face plant, right? And at time t equals 0 is at the starting line. He's ready to accelerate to the opposite wall As t approaches 6 seconds, he has to slow down, stop just for a nanosecond to touch the wall, turn around, and sprint back to the starting line. His distance in feet from the starting line with respect to the number of seconds is modeled by the graph. What are the key features? First off, what shape is this?
Parabola.
It's a parabola. Good. Would we call this a frowny face parabola? No, we say it's negative parabola. Okay, it does make a frowny face, but have to remember it's negative. What are the units involved? What's this unit? Time. What's the other unit? Distance, and I think it's in feet. Yeah, because it says 90-foot wind sprints. Okay. What's the parent function? Y equals x squared. Good. What transformation to the parent functions are being done here? Keep in mind, this point here is the point, I believe this is, does that say 5 comma 90? 6 comma 90. Okay. So what transformations are happening? It's going what?
It's negative.
It's a negative in front because it's flipping. Good. What else do you know about it?
It moves
It moves how many to the right?
3.
6.
No, careful.
Oh, 6.
6.
Yeah, so it'd be
2, 4, 6, not 1, 2, 3, okay? And then it moves up how many?
90.
90, very good, okay? From there, I will allow you to finish this as part of your work for tomorrow, and we'll finish it up when we get to tomorrow. All right, at this point, quiz time.
Oh my god.
Okay.
When you get done with your quiz, if you want to go get your Chinese food and heat it up. Okay?
You should have seen how much Chinese food we had yesterday. Me and Molly made confirmation we had a party.
Oh, yeah?
And there were trays like this. Yeah, filled with Chinese food. And it's all in my fridge.
Really? And you didn't think for 1 second about bringing it to class to share a little, huh?
It's so good. Yeah. She said I could bring you food at night.
Ooh, look at that. There you go. And you said no, obviously.
I brought them, I just ate them already.
All right, here we go. Parker, can you hit the lights, please? You all right today? Look like you woke up a little late and you just knocked them over the shelf today. You know what I mean? You know what's really good? That the Chinese, what is it? Fried raviolis, is it? Oh no, fried cream cheese raviolis. That's what it is. It's really good. Chinese food. It's an appetizer. You should get it. They're rocking. All right.
Today's 22nd. 21st.
On the equations, take a look. Ready? Read number 3 with me. Guy and Jim work at a furniture store. Guy is paid $185 a week plus 4%. On the first equation, you got to make it 0.04x. Right? Read the equation. G of x is 185 plus 0.04x. And the other one is good. Okay?
You wanna go get your Chinese food? Thank you. Parker, why didn't you keep going on the equation? You're doing fine.
I forgot. I forgot the rest of it.
Oh, it's like a pretty basic guy. It just has some ugly numbers in it, but you do it the same as, if I said to you, 7 plus 3x equals x plus 5, it's the same exact thing, just with uglier numbers. Karen? Where did that come from? Just the brain cramp? Okay. You know what I'm noticing is all of these hundreds, and what it's saying to me is, wow, when you guys actually pay attention and go over your mistakes, you get things right. So that should happen on like, all, okay, put it in the nuke. Okay. It's easy, it's just a dial, it's an old one. You should be able to do this all the time.
What? I've never seen it. I don't know what this is.
Open the door, take the lid off. Yeah, very important to take the lid off or you'll melt the plastic. Stick it in, shut the door, turn to about 2 minutes. Wow, everybody give her a round of applause.
You know you can't put a can over.
Yeah, you can't put metal in a microwave.
I can put metal in a microwave.
No.
It's like a storm.
You're gonna put it right in front of it. One time I put like the rice thing. You could have said that, but then you should write the rice in it, and I forgot. And then like,
Sparks all over.
Oh, the thing from Chinese food.
I did it like a second before everything happened. I don't like you.
I was gonna say I really care.
All right, everybody's had their quiz in? Everybody has a quiz in? Okay, I'll pass it back to you. Andre? Lily? Savannah? Dominique? Sarah? Molly? You guys can talk quickly with each other about your mistakes. Minor? Michelle? Olivia? Sid? Parker?
Worse than the first? That's great.
Karen? Leanne? Don't leave without your quiz. Wilfredo?
That's big, minor.
Savannah?
That's big. It was a hard word.
Mia? Hey, oh, okay, it's not too hot? Okay. Wyatt? Kia? And Catherine?